All right, so we're going to go over how to evaluate a numerical expression with rational exponents. Okay, so we have about 6 examples that we're going to look at. First one being 4 to the power 5 over 2. Now the first thing I'm going to do, I'm going to look to use my exponent rule. So I'm going to take the base of 4, okay, and I'm going to do a factor tree. 4 is 2 times 2, which can be expressed as 2 squared. Okay, now I'm going to put that in parentheses. The 4 is being replaced by 2 squared, and then I'm going to leave this exponent here. And then I'm going to use my exponent rules. Okay, so this is 2 times 5 over 2 is 2 to the 5th. Now I can either leave this in exponent form, or I can actually evaluate 2 to the 5th power. Just 2 times 2 is 8, times 2 is 16, times 2 is 32. Okay, so 32, or 2 to the 5th. Both are acceptable answers. So let's go ahead and look at another one. Let's say that you have 216 to the 1/3 power. So I'm going to start with the factor tree for 216. Now I'm not sure what factors I have here, but it's even, so I'm going to start by dividing by 2. And I'm just going to keep dividing by 2 to see what I end up with. Okay, so I noticed that I divided by 2 3 times, and then I have 27, which is 9 times 3, 3, 3. Okay, 1, 2, 3, 1, 2, 3. So I end up with 2 cubed and 3 cubed. I'm going to use my exponent rules, and I'm going to distribute my 1/3 power. 3 divided by 3 is 1. 3 times 1/3 is 1. And so I end up with 2 times 3 is 6. Okay, so let's go ahead and look at a third example where we're going to add a negative. Okay. Quantity negative 27 to the 1/3 power versus negative 27 to the 1/3 power. Okay, very similar when you first look at them, but here the negative is included with the 27, and here the negative is not included. So I'm still going to use my factor tree. Negative 1, 27. Now using the tree from above, I know that 27 is 3 times 3 times 3. So this is negative 1 to the 1st power and 3 cubed. So I still have the 1/3 power here, so I'm going to distribute. Okay, so this is negative 1 to the 1/3 and 3 to the 1st. Okay, now the part here, when you have a fraction exponent, you have a power and a root. The numerator represents the power and the denominator represents the root. So this is really, okay, negative 1 to the 1st power, okay, the power doesn't move, turns into a cube root. Now, negatives are tricky because negative 1 cubed is actually still equal to negative 1. So I'm going to replace this over here. Okay, replacing the 1st power with the cube power because they are equal. Okay, and leaving this. So we get negative 1 times 3, which is just negative 3. Okay, over here, the negative is not included in the power, which means that my factor tree, so I'm going to add grouping symbols to make this clear. This is what I'm evaluating. Once you become familiar with your factor trees, you don't necessarily have to show it every time. Distribute. Three to the first power is 3. In this particular example, you see that we evaluated to the same quantity. Can you think of a case where they would not evaluate to the same result? Good. Let's take a look at what would happen if I had an even power. Okay, let's do, we'll keep this negative 27 to the 2/3. Okay, so I've got a lot of the same work here. So I'm going to rewrite this. Okay, negative 1 cubed, 3 cubed. Okay, I'm going to distribute my exponent. Okay, so that leaves me with a square. Well, negative times negative is positive. 3 times 3 is 9. And the result is positive 9. Similarly, if I were to evaluate negative 27 2/3. Now, I'm going to add the grouping symbols. If I wanted the negative inside the grouping symbols, I would have written it like the previous example. Okay, so my factor tree is, okay, the negative stays there, nothing's happening. Okay, so I distribute. We get 3 times 2/3 is 2, and the negative stays. Okay, negative 9. So you can see even powers, when negatives are involved, you have to be very careful. All right, let's go ahead and look at what happens when you get some negative exponents. Okay, first thing I'm going to do is rewrite this with a positive exponent. In order to go from the negative to the positive, I need to reciprocal inside quantity. Okay. Now I'm going to do my factor tree. So 27 is 3 cubed. Okay. 1. 1 is the same as 1 cubed. Okay. Why did I pick the 3 exponent? Because I wanted it to reduce with my 3 denominator. Okay. Now let's distribute our exponent. Okay. One over 9. Okay. Let's look at another example. 27/64 negative 2/3. Okay, first thing I'm going to do is deal with the negative exponent. I'm going to do that by reciprocating the inside. Then I'm going to do my factor trees. Okay, so over here, 64, 2, 2 and 16, 2 and 8, but I know that 8 is 2 cubed. So 1, 2, 3, 4, 5, 6. 2 to the 6th. Okay, and I know that 27 is 3 times 3 times 3. Okay, cubed. Now I'm going to distribute my exponent. Okay, so this is 12 over 3, right? 6 times 2/3. 12 over 3 is 4. 3 times 2/3. Okay, and then I can evaluate those powers. 2 to the 4th. Okay, 2 times 2 times 2 times 2. 4 times 4, 16. 3 squared is 9. At this point, you should be able to do the questions in worksheet 1 with the label reference number 4.